Hello, and thank you for tuning in to our presentation about building QGreenland, a free interdisciplinary geospatial data environment for Greenland. Thank you to the session organizers for making this conversation possible. QGreenland is a project beginning our second year that is funded by the National Science Foundation EarthCube program. The project is based at the National Snow and Ice Data Center within the University of Colorado Boulder Cooperative Institute for Research in Environmental Sciences. Our core team includes myself, Twila, as project lead, Trey, Stafford, and Matt Fisher, our project developers, and Lynne, Harden, our education specialist. We're also supported by other personnel at the National Snow and Ice Data Center, and our work benefits greatly from a wide range of collaborators, which we'll talk about more later. QGreenland was an idea several years in the making. In 2013, the Norwegian Polar Institute developed and released Quantarctica, a free open-source GIS tool for researchers, educators, operators, and managers focused on Antarctica. It provided a wide array of Antarctic data all in one easy download, ready for use in figures, for analysis across datasets, and for teaching about Antarctica. It wasn't long before requests began coming in for a similar Greenland-focused tool, but this was not within the purview of the Norwegian Polar Institute. Luckily, we at the National Snow and Ice Data Center were able to connect with a primary Quantarctica developer and move forward to fund the project. It did require finding funding that would emphasize the data and tool building over the science discovery. We were very lucky that the NSF EarthCube program has this focus, to transform geoscience research by developing cyber infrastructure to improve access, sharing, visualization, and analysis of all forms of geosciences data and related resources. EarthCube goals align with our goals to serve geoscientists, to provide interdisciplinary data so that users can explore connections across fields, to create a tool for discovery and teaching, to provide offline for use anywhere in the world, and to do this while still designing and working towards connecting with broader audiences. To give you a sense of how QGreenland is used, let's look at a short use case. You are a geoscientist preparing for your first research project, including work in Greenland. You're going to start by installing QGIS and downloading QGreenland, taking time to explore what is available in QGreenland and even adding your own data layers. QGreenland provides a geospatial foundation to plan field travel and scout local and regional environments. As you step off the helicopter onto the ice, your QGreenland use goes offline, still providing all of the QGIS functionality. So, in-field and in-office data analysis can work hand in hand. As you begin to share your results, QGreenland provides plenty of layers for creating engaging presentation and publication visuals, or for creating teaching or outreach information to share with your research. One of our primary goals is allowing access to users across the globe and across the resource spectrum. So that's why it is so important to use QGIS rather than proprietary software like ArcGIS. Our goal to maximize access is also paired with other development goals that consider future use and reuse. So as we began development, we emphasized creating reproducible automated builds. We're creating a consistent code base with linting to enforce continued consistency, and all of our software development history and documentation is available on GitHub. In this way, other users could even grab our code and use it to more easily develop a geospatial environment for other regions or focused on other topics. We would love to see our efforts used in this way to lower the bar for other QGIS environments to be built. It is no surprise that open source tools and software have been invaluable in allowing us to build this package, including those you see here. One question that we've asked but haven't answered and that we think requires serious community consideration is, How can science better support and fund development and maintenance of open source tools? Will these tools exist and persist if we aren't giving enough attention to supporting them? Collaborations with other institutions and initiatives has also been key. We began at the proposal stage in reaching out to potential partners, especially in Denmark and Greenland, to ensure that we would have widespread support for our tool, help in identifying data and users, and assistance in translating, literally and figuratively, across cultures. Endeavoring to create an interdisciplinary tool meant that we would not simply be able to stick to our expertise at the National Snow and Ice Data Center. A conscientious project design that emphasizes connecting with project partners was called for. One means to do this, and a lesson learned from Quantarctica, was creating an international editorial board. Our 12-member board includes representatives from collaborating organizations as well as other subject matter experts and educators. Their role is wide-ranging, helping to identify and evaluate data, evaluating user and education material, connecting us with other projects and individuals, and sharing QGreenland with their communities. A challenge of tool building is connecting what we build with the many possible user communities. You can see information about what we build on the bottom lower box and potential user communities on the upper left-hand box. The editorial board is part of linking QGreenland to potential users, but just as important is taking seriously the work of designing a usable website and support material. Thorough and visually compelling user information and creating easily accessible how-to information is critical. Having an education expert on our team, as well as professional web developers, helps us ensure our materials are professional and align with what educators or other specific user groups are expecting. We hope to grow our user community into the future to help with product sustainability. Yet another reason to emphasize open source and reproducible workflows. In line with our open source emphasis, one project goal is to use data that is already in trusted public archives. For example, data from the NSF Arctic Data Center, the National Snow and Ice Data Center, Oceot Greenland Survey, and others. The advantages of using these data are manyfold. They are more likely to have full documentation and metadata, they are usually versioned data sets, and we can often use code to interact with the data, improving the reproducibility of our data packages. But we have found challenges on the data front that come in at least two flavors. The first challenge is in working with each individual data set. While QGreenland was motivated to overcome the time and effort difficulties that any one person would have faced when trying to bring together diverse data, we are nonetheless still surprised at how disjointed and inconsistent many data are. We often need to contact data creators to work out kinks in the data or metadata, and seemingly straightforward data sources can quickly become confusing as many data files are combined into a single archive, metadata is incomplete, or spatial data information is not easily linked with research or sampling data. Another area of challenges has arisen as we try to work with multiple organizations across several countries. Not all groups aim for or are willing to provide a public archive of their data, and public archive isn't appropriate for all data types, like sensitive human or wildlife data. Data creation and storage systems may be in flux as well. Many data owners have specific registration requirements for download, often to help them keep track of important metrics that can make programmatic access difficult or impossible. We also find ourselves sometimes struggling with the language barrier, a challenge that can go both ways with sharing information about QGreenland. Right now, we are accepting some data that is not in a public archive, and we are trying to balance serving data from partners and key Danish and Greenlandic sources with maintaining fully open source and open data ideals. We expect this to be a balancing act throughout the project, and it has made it difficult to establish clear project data policies. Nonetheless, we have made excellent progress and expect to release a full version 1.0 in early 2021. Once a person has installed QGIS and downloaded QGreenland, it's as easy as clicking on a single file to open up the QGreenland environment. QGreenland is meant to allow users to explore local detail and large regional data. Since the primary QGreenland data package is meant to be a standalone download that will support offline work, most data have to be included directly. So we have to be mindful of file size. This is challenging for including near real-time or very high resolution and large file size data. You can see, though, that we already have a lot of layers implemented in QGreenland, and you can explore infrastructure, towns, or also data and metrics about the ice sheet or the ice ocean area. You can take measurements, do analysis on the data, as you can see here, and you can also consider information at many different scales. We've even included data that, for example, might include future projections of the ice sheet extent, like you can see here. To help with the challenge of seeing local detail and ice sheet-wide information, we have implemented some online-only access layers that connect to an outside server to provide data. For example, this high-resolution Sentinel satellite imagery is an online-only layer that provides enough detail to identify buildings and infrastructure. As we zoom out, we can make better use of layers that might lack very fine local detail, but provide the ice sheet-wide perspective useful for many researchers. And of course, the GIS environment allows users to look at relationships between data sets. Looking to the future, there's a lot to come from the QGreenland team. Anyone can play with the current QGreenland beta version, and we'll have a stable version 1.0 release at the start of 2021. Along with that will come a variety of training material and virtual training workshops. We'll also begin to develop middle school through college level teaching material and increase our focus on building a community of users. We're also beginning to think about sustainability and considering what paths there are for moving forward. For example, we might be able to transfer the QGreenland project to a partner organization following NSF funding. We'd love to hear ideas from other projects on any of these fronts. We'd also love to have your participation and contribution in other areas. You can visit our website to sign up for our newsletter, which comes out about quarterly, or begin to use QGreenland right away via the beta package, which you can see already contains a lot of data. We also really value ideas on data improvements or possible connections, and we would love to have you share this resource with your communities. GitHub pull requests are also welcome. So please be in touch, and we look forward to connecting. Thank you so much.